If we emit some carbon dioxide today, some of that is going to be hanging around in the atmosphere hundreds of thousands of years from now. In contrast, if we emit methane today, nearly all of it will be removed from the atmosphere within a few decades by natural processes. Carbon dioxide is relatively dilute in the atmosphere, which makes it hard to capture, but methane is much more dilute, which makes it even harder to capture. And so the fact that methane is so dilute in the atmosphere and that natural processes remove it from the atmosphere within a few decades, to me, makes carbon dioxide the main focus of the greenhouse gas removal effort and not methane. That said, methane is a much more potent greenhouse gas. One of the real questions is, what are you most worried about with climate change? And some people are very concerned about the climate change that's happening now and might happen over the next decades. And other people are more concerned with what might happen over future centuries. And whatever we think is happening now or might happen over the next decades, if we don't greatly reduce our greenhouse gas emissions, what happens in future centuries is much worse. The big ice sheets will take a long time to melt, but we'll see something like maybe different people argue about how fast the ice sheets will melt, but if they all melt, the ocean goes up around 60 meters, something like close to 200 feet. And it'll take time to do that, but we'll see like century after century of increasing sea levels. There's parts of the tropics that, if it gets too hot and humid, no matter how much you sweat, you can't cool your body enough. And in warm times in Earth history, near the tropics, there was no animals bigger than 2 kilograms or so, let's say 5 pounds. And because it was the only things that could survive in these hot temperatures were things that could burrow in the daytime and stay in a cool burrow. And so there's the potential of making parts of the tropics essentially unlivable by humans who are not in air-conditioned or other temperature-controlled environments. And so, this thing of lethal temperatures and melting ice sheets and this sort of thing will start to happen in the next decades, but really could get into full swing later this century and in future centuries. And so if you're mostly concerned about the long-term legacy of what we're doing, then it's really CO2 that you're mostly worried about, and you want to focus on CO2 removal and CO2 abatement. But if we are seeing incredible heat waves and droughts and things like this now, and they're only going to get worse in the next decades. And so if your primary concern is what's happening in the next decades, then control of methane becomes increasingly more important. And these are basic value judgments of how do you value the distant future versus the near future. There's no technical way to say which is the right thing to focus on.
But certainly, I mean, from a methane point of view, from a methane point of view, what we're seeing in within the permafrost areas of the planet implies that there's a dramatic acceleration going on there.
Yeah, as temperatures warm, permafrost melts, and there's methane locked up in the permafrost, and so that permafrost gets released to the atmosphere, and that's part of a positive feedback. But still, most of the warming of the high latitudes is coming from the CO2.
Sure.
And so, addressing CO2 to me is still primary. The other big concern is, and maybe this is a longer-term concern, that there's huge amounts of methane locked up in the continental shelves in sediments under the seafloor. And it's thought that that will take a lot of time for that heat to penetrate into these sediments and allow the methane to be released to the water column. But there's some evidence that at some times in Earth history, as these clathrates or this sort of methane ice melted, that landslides formed and catastrophically released large amounts of methane. So, I mean, there's certainly risks, methane-related risks, and I don't want to downplay them. But, you know, with regard to methane, you know, I would really focus on, right now in oil and gas fields, there's a lot of methane leaking out of wells, and you know, and many of these leakage points are not being addressed. And so I think just addressing methane leakage out of gas fields is a key thing. Also, gas pipelines, some of the valves and so on the pipelines are actually designed in ways that the methane's released as the valves change. And then if you go into urban environments, you know, in cities like Boston with these old gas pipelines through the city, that they're leaking substantial amounts of methane. And so I think you know, well, methane removal may or may not be justified economically or other ways, that certainly a focus on reducing the leakage of methane today is really important.
Can I just go back and talk about the, I mean, reduction and removal shouldn't be mutually exclusive.
Right.
Your thoughts
Yeah.
on the partnership between them?
So, you know, one of the things, so typically it's cheaper to avoid making a mess than to make a mess and have to pay to clean it up later. And so the focus needs to be on us not making a bigger mess out of this planet, which means focusing on emissions reduction. And so if you say, oh, if we wanted to have a bigger impact on methane or CO2 concentrations today, and we had $1 to either put on emissions reduction or methane or CO2 removal, you'd say, okay, it's more effective to put that $1 on CO2, on emissions reduction. However, technology doesn't just exist in a vacuum. That we see with Germany's and other countries' investment on solar photovoltaics, how this Energiewende program of Germany, which really accelerated deployment of solar photovoltaics, resulted in manufacturing improvements in China and other places, which have really dramatically brought down the cost of solar photovoltaics. And so even though 20 years ago solar photovoltaics were super expensive, it was really good that Germany did all of this investment in deploying this expensive technology, because it brought down the costs, and now people have cheaper solar photovoltaics today. And in many of our simulations using current prices, if you just want bulk energy in California, often solar is one of the cheapest ways to provide it. And so there's a learning benefit to start doing expensive technologies today. And so I don't think that methane or CO2 removal is justifiable as sort of the least cost way to reduce climate risk today. I think the rationale for doing it today is to learn how to make these technologies cheaper so that they could become a least cost way of reducing climate risk in the future. One thing that we see, we do some simulations of energy system models, and I mean, we do energy system simulations using mathematical models, and the last little bits of carbon dioxide removal, let me start over again. We do mathematical simulations of zero emission energy systems. And often getting those last bits of emission out of the energy system is really hard. I mean, think if you have some cabin in the woods somewhere that you know that needs to be heated. Well, maybe they can burn some wood or something, but you know, it's really hard. You know, it might be that for them to burn some fuel, carbon-bearing fuel, might be the way that they can heat their home. Maybe I can try to say that more succinctly. We do mathematical modeling of least cost, zero emission energy systems. And in many cases, getting rid of the last bits of greenhouse gas emission is really hard. I mean, examples of things that are hard to get rid of is emissions from long distance aviation. If you're flying from New York to Sydney, there's few fuels that are as dense in terms of mass and volume as aviation fuels. Or another really tough one is the heating loads of homes and commercial enterprises in remote areas. And for these things, the idea that, well, maybe you just let them burn a carbon-emitting fuel, and then you have an air, some kind of air capture, carbon dioxide removal system that can work 24/7, and so your let's say the home heating's episodic on cold winter nights, but the carbon dioxide removal can operate, around the clock, around the year, and it can be a cost-effective way to get the last bits of emission. This other question about reducing atmospheric CO2 concentrations, if I were, benevolent dictator of the world, I might say, oh yeah, let's do that. Let's draw down CO2 concentrations or even methane concentrations. But, there's not a long history of societies coming together to allocate resources to help people throughout the world and on long time scales. And I hope we can organize ourselves to do that. But most of human history, most people have operated in ways that seem to advance their narrow self-interest. And we see the kind of political discord operating in the United States today and in places like France and the United Kingdom. And the idea that we're going to get these disparate political forces to unite on doing something to help the world through the future. Maybe I'm overly pessimistic. I'm hopeful that it may happen, but I'm not. I'm a little pessimistic in predicting that it would happen.
So do you not feel, in light of what you're just saying, that there is a space and probably a need to have this collaboration between reduction and removal? Because, as you say, it's difficult to take the horse to water and drain.
So, I think there's if you think of how much it will cost, economists think right today globally, GDP is on the order of 100 trillion. Today globally, global GDP is on the order of $100 trillion a year. Economists estimate that an energy system transition, to convert our energy system into one that doesn't dump its greenhouse gases into the atmosphere, might cost something like 2% of GDP. So we're talking ultimately investment on the order of $2 trillion a year. And that's a huge amount of money. And the amount of money that being put into carbon dioxide removal and associated things today, might be, well, there was just recently, but anyway, let's say it's might be in the hundreds of millions today. I don't really know the exact number, but that is like 1/10,000th of the total amount of money that would need to be put into addressing the climate problem. And so even if you put, say, $1 billion a year into atmospheric CO2 and or methane removal, that would be 1/2000th of what we need to be spending to do energy system transition. And I don't claim to know the exact balance between this. I see the carbon dioxide removal or greenhouse gas removal as developing technologies that might be helpful in the future, because you would actually get more effect on greenhouse gas concentrations today just putting it into emissions reduction. And so the reason to do the removal today is to get down that learning curve and make it cheaper for the future. And I don't know exactly what balance between learning for the future and reducing emissions today should be, but typically the research and development costs are a small fraction of what it actually costs to transform large-scale energy systems. And so I don't think having a research and development program on greenhouse gas removal is, that's like, I think it's basically in the noise of how much it's going to cost to transform our energy. Wait, let me get that sentence better.
Sure.
Typically, the amount of costs associated with research and development projects are a tiny fraction of the cost that it would take to deploy the energy technologies to convert our entire energy system away from fossil fuel combustion. And so I don't think the amount of money that would be spent on developing greenhouse gas removal technologies would significantly impede efforts to reduce greenhouse gas emissions.